It's Mitchell from Australia, and this is Talk the Line first pre-test. The camera angle on the left is to show the entire experiment and what I'm doing, and the camera angle on the right is the camera I've got in my hand. So there's a metal stake in the ground here, which the winch is attached to. The winch is secured to the barrel, which will be applying the force to the Spectra. The Spectra is attached to the dynamometer on this side. It's in line with the dynamometer, with the Spectra, and that 10 meters is just to show that it is a 10-meter test and how much it would have elongated over that test. But as you'll see later, the knot didn't quite hold properly, so that's not valid data for this particular test. Now on this side, the Spectra is connected to the dynamometer in a perpendicular angle. Now this is just a test between the dynamometer in line with the Spectra and compared to perpendicular angle, because I will need it at a perpendicular angle in the water because these dynamometers are not waterproof. So I'm just showing the difference between those two angles. Now the camera angle on the bottom left that just showed up there is the far dynamometer, the perpendicular one. And the right camera angle is now the closest dynamometer in line with the Spectra. Now I'll just give it a quick test, and it's around about 0.31 millimeters at rest. And as I start putting some tension onto it, the knot is actually slipping. So I'll have to redo the knot, but this is a good way to show you the knot that I was using. But I will no longer be using it because this, although this knot was meant for use with braid, Spectra needs a different sort of knot, because this knot was actually digging into the Spectra line and causing it to break before it even got to the rated tension, as you'll see later in this video. So the rated strength of this line is 50 pounds with a 78-pound breaking strength, but it got nowhere near that strength in this test. Now that's the knot that I used, and it doesn't slip from here on out in this video, but this is just a good visualization of what is actually going on in this experiment. Now I've reset the dynamometers and started to apply force via the winch. Now under a bit of force, the Spectra was about 0.32 millimeters, which is the manufacturer's specifications. And I continued to check this throughout this test, and it was all around 0.31, 0.32 millimeters using this digital caliper. So as you can see, compared the dynamometer on the left in a perpendicular angle is a bit different to the dynamometer on the right. Around about 2 or 3 pounds at this stage. So it's still about 0.32 millimeters. And I was checking it along the line. Now this is the point where the Spectra breaks, only at about 28 or 29 pounds force. That's on the right camera angle with the Spectra in line, and on the left camera angle is the perpendicular angle, which is about 3 pounds difference. Now it has gone about almost 500 millimeters, but that cannot be used because the knot was slipping. And this is just to show what the Spectra ended up like when it did snap. Now, as I said, the more tests that I do, the more things I've found out what needs to happen and what I'm doing wrong, and there is even more things that I haven't even found yet. But this is just a good visualization for everyone to see what is actually going on in this experiment. And the coming videos that I will be releasing is with the new knot, and that is a better indication of how this experiment will carry out. So stay tuned, and thank you for watching.